Hi everyone, this is RJ Enseñado and welcome back to my channel, GTR Math Tutorial. So in this video lesson, we will discuss a test for two population means. So testing hypothesis for two population means for large samples. So here's our formula. So Z is equal to x bar sub 1 minus x bar sub 2 all over the square root of sigma sub 1 square over n sub 1 plus sigma sub 2 square over n sub 2. So where x bar are the sample means, sigma are the standard deviations, or sigma square are the variances, and n are the sample size. Z is the Z test. So we're going to use the Z table for this lesson. Okay, so we have two groups. So n sub the first group is the subscript 1 and the second group for the subscript 2. Okay, so in order to use this equation, meron tayong two rules. So first, n sub 1 and n sub 2 must be n sub 1 and n sub 2 must be greater than or equal to 30. For less than or equal to 30, we have another formula. So we will use the t-test for that. So for now, so we're going to use the z-test for two population means. So n sub 1 and n sub 2 must be greater than or equal to 30. And another is n sub for the the two samples must be independent. So ibig sabihin, yung appearance nung sa sample natin sa first ay walang kinalaman dun sa second. So independent dapat. Hindi nakakaapekto yung pag-select ng sample natin dito sa first tsaka dun sa second sample natin. Okay, so kailangan natin ng dalawang groups with sample means, standard deviation, and sample size. So since sample size ito, we're going to substitute the value of sample standard deviation for the sigma. Since n is greater than or equal to 30 according to central limit theorem, so habang dumadami yung sample size natin, na-approximate niya yung sa normal distribution. Okay, so example number 1. Okay, so here's our problem. For example number 1. So again, we will use the 5 steps in testing hypothesis. First is state the null and alternative hypothesis. Second step is the level of significance. Third test is the test statistic. So in this video, we will use the z-test since this is a test for two population means for large samples. Then fourth step is the decision rule. And fifth step, make a decision. So it's either to accept or do not reject or do not reject the null hypothesis. Of course, if we reject the null hypothesis, we will accept the alternative hypothesis. Okay, so first example. So the admission officer at a university wants to investigate whether there is any difference between the scores on the mathematics placement test of students who attend classes primarily during the day and those of students who work during the day and attend evening classes. So here's the data. So we have student, day and evening, who attend day and evening classes. So the mean for students who attend the day classes is 19. Standard deviation is 12 and then sample size of 40. Okay, then for evening classes, we have mean of 94, standard deviation of 15, and sample size is 50. So we're just going to compare. So as you can see, the mean are different. So mean for day classes is 90 and mean for evening classes is 94. So for evening classes, the mean score is greater than the students that attend the day classes. But again, we cannot conclude that there is a difference between the score on the mathematics placement test because the difference can be due to sampling error. And as you can see, the standard deviation of the day and evening classes are different. So 12 and 15. So that means the spread of although the evening classes has a greater score, but it also has the greater variability, which is 15. So that means the spread of the scores in the evening classes is spread out. So magkakalayo. Okay? So compute Z and arrive at a decision. Use 0.05 level of significance. Okay, so let's apply the 5 steps in hypothesis testing. So but first we will we'll write the given. So here's the given. So we have, I'll just write the given. So these are the x sub 1, x bar sub 1 is equal to 90. Then S sub 1 for the sample standard deviation. So we're going to substitute the sample standard deviation to the formula sigma. So S sub 1 is 12 and then N sub 1 is 40. Okay, so for the evening classes, so we have x bar sub 2 is 94, S sub 1 or S sub 2 is equal to 15, and then N sub 2 is equal to 50. So these are the given. So now we're going to apply the 5 steps. So let's erase this the formula. So first step is the null and alternative hypothesis. So let us state first the null and alternative hypothesis, or H sub O, H sub 1. So we can use H sub O, H sub 1, or H sub 0, H sub 1. Okay? So how to determine the null and alternative hypothesis? So just look for the keyword. So what is the keyword? Any difference. So we want to find the admission officer at the university wants to investigate whether there is any difference. So paghahanap ng null and alternative hypothesis, hanapin nyo dapat yung merong difference or yung merong less than, greater than. So yun yung hahanapin natin. So in this example, ang hinahanap lang natin is whether there is any difference. When we say any difference, kino-compare natin yung population mean. So, in comparing two population means, the null and alternative hypothesis is like this: mu sub 1, then mu sub 2, mu sub 1, mu sub 2. So, mu sub 1 is the population mean for the day classes, and then mu sub 2 is the population mean for evening classes. So, we will use the sample. The sample size 40 and 50. So we're just going to write the symbol. So the symbol that we use in hypothesis are equal and not equal, or greater than or equal, and then less than, or less than or equal, then for alternative is greater than. So which pair of symbols or inequalities are we going to use? So the keyword is any difference. So when we say any difference, so the symbol that we're going to use are equal and not equal. So there is no difference, meaning the population means are equal. So there is no difference. So if there is any difference, meaning the mu or the population means are not equal. Okay? So wala naman tayong nakitang less than or greater than na gusto nating i-investigate. Kaya ang null and alternative hypothesis natin ay mu sub 1 equal mu sub 2, and then for alternative, mu sub 1 is not equal to mu sub 2. Okay, so ito yung mga given natin. So ano ang ating level of significance? So step 2, level of significance is given. So use 0.05 level of significance. So So alpha is 0.05. And then we will use two-tailed. Why two-tailed? Because of the symbol equal and not equal. So if we use greater than or less than, so that is one-tailed. So 0.05, two-tailed. Then third step is what is the test statistics that we're going to use. So the test statistics is z-test. Why z-test? Because n is 40 and 50. So large samples, greater than or equal to 30. So we're going to use z-test. So if it's less than 30, then we're going to use t-test. Okay, so fourth step is the decision rule. Okay? So hindi natin kailangan ito. Okay, so decision rule. So this is for the computation. So just write the formula. Z is equal to x bar sub 1 minus x bar sub 2 all over square root of sigma sub 1 square over n sub 1 plus sigma sub 2 square over n sub 2. So that's the formula. So for the decision rule, so we're going to use the z table. So what is the critical value for, since this is two tests, so we're going to divide 0.05 to 2. So divide 0.05 to by 2. So this part is 0.05 divided by 2. So this part is 0.0250. So we're going to use 4 decimal places. So we will look in the z table, find the closest value, or if there is no exact value, find the closest value to 0.0250. So we will use the negative part of the z table. So find the 0.0250. So the critical value for the 0.0250 is negative 1.96 and then positive 1.96 to the right side. So since two-tailed, divide 0.05 by 2, so we have 0.0250. Then look for this value in the z table. Okay, so now the decision rule is if the computed z is between negative 1.96 to positive 1.96, accept. Okay? So pag nasa, ito yung acceptance region, ito yung rejection region. Okay, so the decision rule is if the computed z, so c sub c for computed, is greater than 1.96 or z sub c is less than negative 1.96, reject the null hypothesis. So reject the null hypothesis H sub O. Okay? So here's the decision rule. If the computed z is greater than 1.96 or less than negative 1.96, reject H sub O. Otherwise, do not reject. So now we're going to solve. We're going to solve the z using the formula. So just let's substitute the given. We have z equals x bar sub 1 is 90 minus 94 over square root of sigma sub 1. So we have 12 squared over 40 plus sigma sub 2. So 15 squared over 50. Okay, so just use your scientific calculator. So just subtract the numerator. So we have 90 minus 94, that is negative 4. And then, how to type this in your calculator? So to type this in your calculator, just press square root and then put a parenthesis symbol. So just type 12 squared divided by 40 plus 15 squared divided by 50, then parenthesis. So that's how to solve this in your calculator. So if you want to solve it directly, so we can put parenthesis 90 minus 94. Okay, then parenthesis. Then divided by this term. Okay? So kukuhanin muna natin to. So we have square root. So parenthesis symbol. 12 squared divided by 40 plus 15 squared divided by 50, then close parenthesis. So the answer is 2.8460. So no need to copy all the numbers since we only want 2 decimal places for the final answer. Okay, so 2.8460. Then just divide. So therefore, the computed C is, so we have negative 4 divided by the answer. Oops. We have 4 divided by 2.8460. The answer is negative 1.441 if we round down to 2 decimal places. So therefore, the value of Z is negative 1.41. So where is the point negative 1.41? So the middle is 0, so negative 1.41, so banda dito. So since the computed Z is not in the rejection region, so here's our conclusion. Since the computed C is not in the rejection region, so therefore, we're going to accept or do not reject the null hypothesis. So if we say do not reject the null hypothesis, we will accept the null hypothesis. So that means there is no significant difference between the scores, test scores of the students in the day and evening classes. So the difference is due to sampling error. So 90 for day classes and 94 for evening classes, the difference is due to sampling error. Okay? So sampling error lang yun. So there is the conclusion is there is no significant difference. So for evening classes, hindi nakaka-apekto yung work nila para dun sa test nila. Okay? So that's example number 1. So next example. Okay, number 2. A sociologist asserts that the mean length of courtship is longer before a second marriage than before a first. She bases this claim on the observation of 1, so this is the first group, 80 first marriages in which the average courtship is 265 days with a sample standard deviation of 60 days. So, and number 2, so this is the subscript 2, the second group, 60 second marriages in which the average is 268 days with a sample standard deviation of 50 days. So, test her assertion using the 0.01 significance level. Okay, so sulat muna natin ang mga given. Meron tayong 2 groups. The first marriages, and then for the second group, we have second marriages. Okay? So for the subscript 1, we have X bar sub 1, the mean, the sample standard deviation, and the sample size. So for the first group, so we have 80 first marriages. So 80. For the first group, 80 first marriages with average of courtship is 265 days with sample standard deviation of 60 days. Okay, so we have N is 80. We have mean is 265 days. And then standard deviation of 60 days. Okay, so for the second group, we have, so group number 2, the second marriages. So for we have sample size of 60 second marriages in which the average is 268 days and standard deviation is 50 days. Okay, so we have x bar sub 2, s sub 2, and n sub 2. So n sub 2 is 60, mean is 268, and then we have 50 days for our standard deviation. Okay, so it's the given. Okay, so next step is the state the null and alternative hypothesis. So the null and alternative hypothesis for comparing two population means, so we have mu sub 1, mu sub 2, and then mu sub 1, mu sub 2. Then let us analyze which symbol are we going to use. So is it equal and not equal, or greater than or equal and then less than, or less than or equal and then greater than? Okay, so analyze the problem. So a sociologist asserts that the mean length of courtship is longer. So that is our keyword. The mean length of courtship is longer before a second marriage than before a first. So that is our keyword, is longer. So that means, so for mu sub 1, this is the mu sub 1 is the first marriage. So for mu sub 1, this is the first marriage. And then for mu sub 2, this is the second. And then we're going to put the greater than or less than in the alternative hypothesis. And then the inequality with equal sign, greater than or equal or less than or equal, in the null hypothesis. So we have mean length of courtship is longer before a second. Before a second. So this is before a second marriage. So mu sub 2 for the second marriage is longer. So that means mu sub 2 is longer, so greater than. So mu sub 2 for the second marriage is longer or greater than. Or if we read that from left to right, so mu sub 1, since the second marriage is longer than the first, then the length of the first marriage is less than the length of the second marriage or the length of courtship before. Okay? So the partner of this for the null hypothesis is greater than or equal. So that is our null hypothesis and alternative hypothesis. So always put the less than or greater than in the alternative, and then the symbol with equal sign in the null hypothesis. Okay, so we're going to test this. If the assertion of the sociologist is true. So this is the first step. So second step is the level of significance alpha. So level of significance alpha is 0.01. And then, what is the, is it two-tailed or one-tailed? Because of the symbol greater than or less than, mu sub 1 is less than mu sub 2. So this is a one-tailed test. One-tailed z-test. So step 3 is z-test. Again, why z-test? Because the sample size are large. 680 and 60. So we're going to use the z-test. So next step is the, yan. So tanggalin na natin. So next step is the decision rule. Okay? So decision rule. So decision rule, we're going to use the, okay, draw the rejection region. Okay, so since it is one-tailed and h sub 1 is mu sub 1 less than mu sub 2, then the rejection region is in the left side. Okay? So left side. So this is the rejection region. So the 0.01 rejection region is all in the left side. So look for the 0.01 or 0.0100, closest to 0.0100 in the z-test table. So if we look in the z-test z-table, so the value of that is closest to 0.0100 is negative 2.33. Okay? So therefore, the decision rule is, decision rule, reject the null hypothesis if the computed C is less than negative 2.33. So otherwise, do not reject. Okay? So now compute. Use the formula. Z is equal to x bar sub 1 minus x bar sub 2 over square root of sigma sub 1 square over n sub 1 plus sigma sub 2 square over n sub 2. So substitute all the given. So we have 265 minus 268. 265 days ang length of courtship daw before a first, then before a second. 265 minus 268. So again, there is difference, but we're going to find out if the difference is due to sampling error. Over square root of sigma or sample standard deviation. So substitute in the sigma since it is large. So we have 60 squared or 60 squared over 80 plus, so sigma we have 50 squared over 60. So compute. The numerator, 265 minus 268, that is negative 3. And then for the denominator, so just type this, square root, and then parenthesis symbol. So press square root, parenthesis symbol. So just type that, 60 squared divided by 80 plus 50 squared divided by 60, parenthesis symbol. That is equal to 9.30949. Ayun, 949. So, divide lang natin yan. So, we have negative 3 divided by 9.30949 is equal to negative 0.32. So, rounded off na yan. So, negative 0.32. So, again, where is the point negative 0.32? So, negative 0.32. So, the middle is 0. This is 0. So, negative 0.32 is in the acceptance region. Okay? So, negative 0.32 is not less than. So, it is greater than negative 2.33. So, therefore, the correct decision is do not reject the null hypothesis. Ibig sabihin, if we do not reject the null hypothesis, so if we do not reject the null hypothesis, we're going to accept it. Okay? So the conclusion is, do not reject the null hypothesis. Therefore, the length of courtship before the first is greater than or equal to the second. So therefore, the assertion of the sociologist is false. Okay? Because we're going to accept this, mu sub 1, the length of courtship, the mean length of courtship before the first marriage is greater than or equal to the second marriage. Okay? So we're going to accept this. Okay? So the mean courtship length is greater than or equal to the second. So again, the assertion of the sociologist is false, that reject natin yon, that the mean length of courtship is less than before the first, and then before the second. So accept this. Okay? So that's all. I hope you learned something. So please like, share, and subscribe. Bye-bye.